Here in Washington with us on the Larry King program and our extended coverage of what happened today is Alex Rowland, professor of the History and Technology and Military History at Duke University. Thanks for coming up.
You're most welcome.
What are your thoughts tonight?
First of all, with Mr. Scott, I share the thought that this is a tragedy, but perhaps an occasion for us to think about the space program. And unlike him, I'm not sure that there is yet a place for civilians in space, nor am I entirely convinced that there's a necessity for any people in space at all. That is, I've yet to be convinced that it's necessary to have manned space missions. I'm of the belief that any specific mission we can identify in space, we can build a machine to do it.
A machine will replace a human being's ability to calculate, recalculate, make judgments?
Yes.
So you would question the space program?
All of those things you mention aren't necessarily things that we're going to do in space. That is, if we're going to invest the money in a launch vehicle and to send a mission up into space, presumably we should know rather clearly ahead of time what it is we want to do up there, what it is we want to accomplish. And I think within those limits, we can design machines to do that capably. And of course, one of the ironies of the timing of this is that we've just seen the magnificent achievements of the Voyager spacecraft going by Uranus, a comparatively inexpensive machine doing truly remarkable things in space. When we know what we want to do, I think we're perfectly capable of building the machines to do that. Perhaps sometime in the future, we may in fact require manned spaceflight, but I don't see the need yet.
Another guest with us in New York, Jerry Gray. He's been listening to what's been saying so far. He is with the American Institute of Astronautics. What do you think about what you've heard so far?
Well, I'd love to agree with Professor Rowland, but I'm an engineer. He seems to be a professor. I think we do need people. Don't misunderstand me. We also need robot spacecraft. We also need automation. In fact, the best combination, as Dave mentioned earlier, sometimes solid propellant rockets and liquid propellant rockets are used better in combination. So people and machines are best used in combination. For example, on the Space Lab flights, we found that many of the scientific findings that we were looking for could not have been accomplished without the people on board. Because unfortunately, Professor Rowland, things don't always work out exactly the way they're designed. And the best possible all-purpose computer is a human being, one that can deal with any eventuality, anything that happens in an effective way. Now, again, don't misunderstand me. I think Voyager is exactly the right machine to have done the job that it was designed to do. But we can't always tell in advance exactly what's going to happen on our space flights. I think the use of people, when they're appropriate, is absolutely essential as we advance and do more and more complex tasks. Eventually, a machine simply cannot do a task when it becomes so complex that the design of the machine requires infinite redundancy and many alternatives as to what might go on. A human being can make quick decisions and can act on them. And that's where we need people.
I surely don't disagree with that, but it's a question of the relative cost of these things. And I'm not yet convinced that any of the activities that we've assigned to our astronauts is worth the cost of sending them into space. And there are two kinds of costs. One is the additional cost of making that spacecraft safe for them, which is a very severe economic cost. And the other, of course, is the human cost, the one that we're suffering today when accidents go wrong, as they're sure to do. When a machine fails in space, that's an economic loss that's replaceable. When people are lost in space, they're irreplaceable. I surely don't argue that we should never send people in space. I'm just not convinced that the missions we've sent them on so far, their presence is really indispensable.
Well, I believe it really is essential to look at the future. I agree some of the missions we're doing today are training for the future. But if we were to look at a future in space which had nothing but machines in it, I'm afraid we would really be limiting our options. Now, the cost of putting people into space is higher than that of putting machines into space, as long as the jobs to be done are simple. When the jobs get to be much more complex, it gets to be cheaper to carry along the support necessary to keep people operating and living in space. And we will be seeing this happen with the space station in the next decade, less than 10 years from now. We need to be prepared for it. We need to do the test piloting. We need to do the preparations for it, just as we did in the aviation field beforehand.
For all of you, a simple question. Are we to anticipate more tragedy as we move along with our space program?
Again, I'd like to draw on the experience that we've had in aviation. Aviation was not without its tragedies. This year probably has been one of the worst we've had in a long time. We will not bring aviation to a standstill because of accidents, however. The services to mankind are too important. We will continue. We might expect that there will be airplane crashes in the future. We might expect that there will be spacecraft accidents in the future, but nevertheless, we will continue.
Before we go to Atlanta to meet our other guest, anyone else here?
I'd like to make a comment, Bernie,
Yes, David.
I'd like to make a comment on the last point. You know, one of the reasons that tragedy is so visible is because we conduct our programs in full view of the world, totally open, and we share the data that we gather and the technology that we develop in general. We share with the world. I think this visibility sometimes is very painful for us, but in the long run, I think it pays off because the scientific community and the technological community and even the philosophical community share in a great adventure, something that expands our universe and expands our horizon. And I think I might comment on one thought that Professor Rowland has. I would submit that one of the reasons that the unmanned planetary probes and unmanned spacecraft have such great success is because of the emphasis and the impetus placed upon the space program by the manned space program. I think the budgets are sustained, and I think the unmanned probes are very important to us, and in conjunction with the manned probes, we have a very viable space program, which I believe most of us hope continue in the future.
Okay, I would surely agree with that the manned space program has given NASA the kind of visibility it needs to support some of the other perhaps less glamorous enterprises, but that's really a sad commentary on the way we make decisions about how to spend our public treasure. That is, that we don't decide on what are really the best missions to do, but somehow or other we have to develop a public relations program and fly missions that are attractive to the people in order to support the other, perhaps more substantial missions.
It might also be interesting if we were to take a look at what the rest of the world is doing. The Soviets have emphasized manned space flight right from the beginning, even before the U.S. did. The Europeans right now and the Japanese are pushing very hard to convert their systems to manned spaceflight. They are emphasizing them at the cost of many of their other things. Even the Chinese are beginning to train astronauts and consider manned spaceflight. Whatever we do in the U.S., overseas they will be continuing manned spaceflight.
On that point, we know that you've already begun calling in. All of the lines are lit up. And when we come back, we're going to join our guest in Atlanta, a professor from Georgia Tech University, as we continue our extended coverage of the flight of the Shuttle Challenger.
All right! Pro's got nothing on this arm, baby.
Oh, a pro wouldn't want what's on that arm off.
Off! I'll have these clean in no time.
In the same temperature?
It's the same mud.
Welcome back. Larry King is away tonight. I'm Bernard Shaw. We're continuing our extended coverage of what happened today down at Cape Canaveral in Florida. Joining us, our fourth guest tonight from Atlanta, Georgia Tech University professor Gary Flandreau. You've been listening. Welcome. You've been listening to what's been said so far. What are your thoughts?
Well, I think it's been a very philosophical discussion up to this point, and I would hope that perhaps we might talk a little bit about implications in terms of hardware development. I think we may have seen in a rather harsh way today some results of some approaches that NASA adopted early in the shuttle program in terms of the way the hardware was developed.
Are you saying that things were not done as they should have been done?
No, I'm not saying that, but I think the attitude right from the start was that the shuttle system would be based on existing technology. And that was the overriding philosophy, and therefore whenever questions came along that seemed to be of somewhat a research nature, they were really put aside, and there were some questions that came up that weren't properly addressed, in my opinion.
Which questions?
Well, these have to do with really seemingly small things in the propulsion system. I have worked as a consultant to the Air Force and to propulsion companies in the development of the solid rockets that were used in the shuttle. And there have been some problems there right along. They seem to be small, but I've warned right from the start that these might develop into something more significant. And I hope that's not what we've seen here in the tragic things that happened today.
Professor, please don't be retiring and reticent. Specifically, when you say small things, what are you alluding to?
There have been some development problems in these solid rocket boosters. Let me mention 2 or 3 of these. Perhaps the one that is most important is the problem that has been experienced with the nozzles on these motors. There have been several flights where there was evidence of the nozzle being within a hair's breadth of failure, and these were in some recent flights. Another problem has been oscillations in the gas flow in the rocket motors. This is a very common problem in solid rockets, and the amplitudes of these oscillations have been getting larger in some of the more recent flights, and there is cause for concern.
We have 3 other guests with us on this panel tonight. Any of you, if you feel so inclined, please respond. But since we have a former astronaut, David, what about some of these things? What about the nozzles on the motors, the oscillations of gas flowing through the rockets?
Well, yes, in fact, there have been some problems with solid rocket motors in the past. I believe these have been corrected, but as you recall, a couple of satellites were temporarily lost in 1984 due to failures of solids. However, I think NASA's done its homework, and it has accomplished a very important achievement in the success of the solids. And today, as I viewed the film, I didn't see any problem with the solids. They were very straight and true. Had there been a burn-through or a nozzle problem, there would have been a corkscrew or a tumble. I didn't recognize any problem. I should hope there isn't any. I think that the conjecture or speculation of what caused the failure today is premature. I'd wait. I wouldn't bet on anything myself right now.
Harry?
I think...
Please continue, sorry.
Well, I think that we have to take a close look at the manner in which the investigation is conducted and the conclusions that are reached. And I doubt that anybody tonight, and I've talked to several people, and I doubt that anybody has an answer. And conjecture at this time, I think, is a bit premature.
Area code 202-898-7600. What do you think? Let's go to the phones. Go ahead, please.
Yes, sir. This is Alan Fritchie from Memphis. I'd like to ask Dave Scott, being a pilot myself, I'd like to ask him his thoughts on the psychological impact on the astronaut crews following an accident, whether it was something that happened today, or in his case, what he went through with the Apollo 1 fire 19 years ago.
Alan, you have a very good memory. As a matter of fact, I was on the backup crew to Apollo 1 until 2 months before the fire, and I can assure you within the astronaut corps, there is total resolution to continue and pick up the banner where these people unfortunately had to pass it. The dedication of the astronaut crew in Houston is no different from when I was there, and I think they would be fully behind flying as soon as possible, as soon as we can identify the cause of the failure and correct it.
Thank you very much, Memphis. Another call.
Bernard, reluctantly, I ask a question of this nature. All the discussions today tended to focus in on mechanical things that may have gone wrong. My question is this: to what degree do we know that something like this couldn't have been an act of sabotage? Reluctantly, I say I ask a question like that. What happens at NASA and at the Kennedy Center to assure the security of the orbiter and all the hardware that goes along with it?
David, you've lived in that environment. You've shuttled back and forth to where the crew's headquarters is located. What about security at the Kennedy Space Center at Cape Canaveral?
Well, in my experience, when I was at the Cape, security was extremely good. In fact, we knew the chief of security quite well down there and had great confidence in his ability to maintain the security of the pad and the whereabouts and the hardware. As a matter of fact, I used to run on the beach in the morning, and I was told at some point that they watched me every step of the way. I think security is very tight, and they're very conscious of not only the value of the hardware, but the value of the lives involved.